I believe that China and IBM have very large qubit models. So what are their speeds? And, let's start by what exactly is a qubit?
So a qubit is just like we talked about, a building block in a method to conduct computation. And essentially the reason why a qubit is so much faster than a bit is because a bit can only process information in 2 dimensions, and a qubit can process information in infinite dimensions. And the best way to discuss this is to think about a path planning problem for a robot. So suppose you have a warehouse robot that wants to get from one side of the warehouse to the other side. And what normally robotics would have that robot do is it would go down each of the aisles and essentially all aspects of the maze until it actually finds the exit point, right, or the endpoint. But with quantum, what it would do is quantum would allow it to analyze all options at once, right?
Mm-hmm.
And so as a result, the amount of efficiency from energy savings, the amount of processing, that power that is saved is immense. And so that's why you have it where qubits are much more powerful methods of computation or tools of computation than utilizing your bits. But to get to the point of the differentiation between the large numbers of bits, IBM recently, I think yesterday, they just came out with their new quantum computer that has, I think it might have like 1,000, a little over 1,000 qubits. Our
Wow.
organization has created simulated quantum computers that have we've simulated between 1 million qubits and 1 billion qubits. But we've had to utilize models, computational models that are inspired by nature and are biologically inspired, so to say. And so by becoming more in tune and more in line with nature, we've been able to gain computational efficiencies and optimizations and improvements that we wouldn't been able to have gained had we used normal computation. And so, for example, right now with AI, quantum computing is the most impactful we see in the AI field. And that's primarily because AI is so energy intensive and computationally intensive. And so what you have to do is quantum almost tricks your computer into thinking that it has these powers that it doesn't or shouldn't naturally have, right? Through things like simulation and hybrid quantum computing. And so essentially what we're doing is we're taking the capabilities of existing computing and we're extending them using a hybrid quantum setup and essentially meeting the standards in that day when our full quantum, not hybrid, full quantum computing comes into ubiquitous existence. And so quantum computers exist now. They're just not ubiquitous because of normally the way that they stabilize qubits in order to make them computationally useful is they freeze these systems and these machines to sub-zero temperatures in order to be able to control and slow down the natural biological processes, right? Or the quantum processes. And so as a result, there's a lot of technology behind it that I feel like is almost irrelevant to a certain extent. Because, for example, think about the internet, right? Everyone can't really tell you how the internet works. They don't know about the IP protocols and, all those other aspects of it, but it does have utility. It does work better than the radio, for example. And so I would compare the type of experience and the user interface and the interactivity that one could have on the internet, comparing that to radio when individuals were just interacting from that perspective, or even the TV, because the TV really isn't an interactive medium, right? Quantum provides you that leap from the radio to the internet, or from white and black TV to the internet, and it allows different experiences, customer experiences, different processes to be much more rich and much more granular and detailed. Another example that I'll give you that I feel like will help is time. So one of the issues with computing in today's age is that in order to go faster, you have to break down time into smaller increments. But that's difficult for modern computers, right? Like modern computers start to break down at the microsecond level. And so as a result, quantum capabilities can give you that granularity where you can break down time into smaller increments beyond what currently you could do on a classical computer. And so for AI, for real-time systems, where you have a car that needs to stop when it sees a pedestrian, right? That microsecond is the difference between a person's life or a person, not being here on this planet. And so, medical technologies where the diagnosis has to be correct, right? It has to be sensitive enough to ensure that it's giving the correct answer. And so that's why you see quantum already in society in areas like GPS systems, right? Quantum's already in GPS. Quantum is already in laser. Yeah, it's already in GPS. It's already in lasers. It's already in MRI machines for scanning for things like cancers and tumors because it has to be sensitive. And so most people just don't know that it's being utilized. Is just not ubiquitous because the technology has not been accessible.